Well, this CRT is something special, okay, right? It's a high-definition Sony KV-27HS420, and it's in the shop this week to get serviced, checked up on. It's got some problems according to its owner, and I want to feature it because there's a lot of misconception and straight up wrong information out there about these TVs and whether they are actually great for retro gaming and modern gaming, or are they really not so great? Today we're going to look at this thing first in a couple of ways. We're going to check out this TV as it comes in, go through an initial inspection, talk about what's supposedly wrong with it. Then we're going to get into servicing the hardware and do that in a lot of details. Now, if you're new to this channel, that's pretty much what we do here. We work on CRTs and old technology. And if you do enjoy these videos, I'd appreciate a thumbs up. And also check out if you're still subscribed to the channel. I have gotten some people tell me they're not getting notified of any new videos or that they've been unsubscribed to the channel after a while. So if you do like this kind of content, please check your subscription. Also note that I'm not like producing a ton of content these days. All of my content for the most part is here on YouTube, but it's just I'm not doing like many videos each week. It's more of like a once every week to 2 weeks video. And so if you're just worried about me flooding your feed with all kinds of CRT stuff that you don't want, don't worry about it. All right, so let's get back to this Sony KV-27HS420. Again, this was sent here into the shop. We're going to first service it, take a look at it. I do want you to stick around, though, because I'm going to go into exactly why there are some follies to this TV that, for some reason, seem to get overlooked by much larger channels than mine. Well, here's the Sony KV-27HS420. This is from August of 2004, a DA4 chassis. Let me show you the input board here. It's pretty interesting. We have an HDMI in with actual separated stereo audio in. 7 inputs it looks like on here. Got some nice analog video inputs. And looks like there's definitely a problem right there. Oh, there we go. With our video input. Again, composite S-video. Videos 5 and 6 are component inputs. Then we can even do the Control S system here with Sony. Now the owner is complaining that this thing will just randomly shut off after using it for a while. So let's set it up and see how it tests out. Alright, this is the front of the Sony. It's got the WEGA emblem right there. Got an additional input down here for analog video. Sony emblem. Got some control buttons right here. Let's power it on. See what happens. Oh, you can hear it powering up there. Rush of energy. Okay, we're in input video number 2, which is that front input. Let's see what happens. We got VHS mode. What else we got here? DVD mode. Oh, there we go. All right, this is interesting. I've got it in DVD mode. This is actually a full screen DVD, but right now it's outputting widescreen mode, which is kind of interesting. All right, so I again have this DVD player down here, and it can actually, you can just press the button on the front and change the video modes. Right now it's in 480p, but it's not showing up so good on the camera, but it is, the image is super jumpy. Let's see if it shows up at all here. I don't know, it's not really showing up as good on the video feed. But that's only happening in 480p on HDMI. Let's see what it does when if I go over here and I press HD upscale. Let's see what mode it goes to now. 720p. And the image is stable, not jumping. And it's in widescreen mode. So my guess is this TV absolutely hates 480p over HDMI, because it's doing great here at 1080i too. I mean, 1080i and 720p, it's fine, but 480p over HDMI is just not looking so good. Well, I switched over to component video from this DVD player. Now currently it's in interlaced mode, and I don't see any jumpiness. Of course, it's 480i over component video, so again, I'm not seeing any jumpiness. What I want to do is, this DVD player is actually pretty handy if I can get the menu and everything to work on it. Okay, so if I go to setup on here, I can go to my video setup, and if I go to progressive, see right now it's turned off. I should be able to turn this on, and let's see what happens. This should go to 480p. Okay, cool. Let's get out of that. There we go. And I'm not seeing any jumpiness. So this thing does like this 480p signal over component, but not over HDMI. So I would not try to use HDMI if you get any kind of jumpiness in your image. I'm going to let this run, see if it shows any issues. I finished running the tests, and I didn't have any issues with performance besides what you saw on that 480p through HDMI. Everything else was fine. If I'm looking in here and I'm seeing things, it does look like this yoke has been reseated, which is fine, and you know, can happen. But if I'm looking here, like over here, it looks like the dust has been removed and the yoke's been reseated. And then the wedges have been installed. So I don't know whether that was done by the owner or someone who prior owned this. But anyway, that's noted. It's very dirty in here. It's got normal amount of dust for being, 20 years old. And again, performs fine. I'm going to dismantle it and take a closer look. We have one primary board down here that I don't think it is actually split in two. You see it's split there, and with that flex kind of adapters that hold those two boards together. And then we have that board right here that connects again probably to the input board. Yes, all the communication wise. So what I'm going to do is I'm going to pull that, and I'm going to pull these two boards, CH and WY. I think both of those should be serviced just because they'll get hot and need new solder eventually. But let's pop this guy right here off and see if there's going to be any kind of a zap for discharge. Alright, let's do some probing. I don't have my normal discharge tool, but that doesn't matter. I can use this one. And just as long as I don't touch any of that exposed metal up there. Just to note, this CRT has been turned off for, let's see, I turned it off at 5 p.m. yesterday. It's 11 a.m. today, so it's been off for a while. Not a full day. Let's see if we get any kind of electrical zap here. Nothing. Yeah, some of these newer Trinitrons have a bleeder resistor installed, so no discharge and nothing to worry about there. I did just pop this off by squeezing it together and removing it, so you can just discharge this anywhere, and it's same thing, no discharge there. So we're safe to disassemble the boards and get them out of here. Alright, I'm disassembling this CRT, and one thing I've found out is that we have some kind of interesting connector here that I either do not have a tool to get disconnected off the neck board right here for this cable, and that goes over here to the flyback, right under there. So I'm not going to desolder that. I'm just going to keep this board with the CRT. I'm also concerned that things like the plastic on these parts, and if I start disassembling things, like start pulling this
red cable out that also goes to flyback, which it can be technically removed from that hole and released from the mechanism inside, but starting to do that, and we might ruin or damage our next CRT socket. A lot of this plastic becomes the Achilles heel of the CRTs as they age, and it develops problems with cracking. Now, I did have to remove this entire contraption. I'm sure that there's not only going to be, velocity modulation probably from this board, but there's probably other controls too that are trying to help out and assist the yoke with things like, sometimes even like rotational controls, as well as, what is the other one? The 29-inch PVM has a board like this that controls a sag. And so if your image sags at the top or bottom, it can sometimes be due to problems with this board. So what we're going to do is we're going to go in here, clean this one, put a fresh coat of solder on here, and change these capacitors right here, because there are some heat sinks where it does generate some heat. And we have some 85-degree rated 20-plus-year-old capacitors. And look, this thing, again, it's mounted on here similarly to the convergence ring setup. So I made marks on it. You can see these marks right here on all sides of it, and made marks on where it was seated right to match it up once I reinstall it. You can even see I added some Sharpie marks here. That's to coincide with those two holes so that I can line all this up once I have this board serviced, reinstall it. And once it's been serviced, I can move on to really this bundle. I'll just pull this whole thing together and maneuver around it at my soldering station. But let's go ahead and get this one taken care of. Well, I removed this whole bundle together. I wanted to show you something down in here. You'll notice there are a bunch of boards all bundled together. They pretty much come out as one solid piece out of the back of the TV. And I want to show you how these are connected, because what I'm doing is I'm going to pull this board with the flyback and the neck board, and this is one that I'll be going through and servicing pretty in depth. So rather than having to pull everything and try to work around with everything, you've got these boards connected by these junction points here. Look at that. There's actual like hooks in here that hold this, and these connections are quite interesting. They do, I mean, look, there's actual stuff like running through them, okay? So it's not like just a mechanical or physical connection. There's actual, a need for these things to be in the right spot and to remain good. So these little things are connected by latches on the sides that you have to kind of softly pull out against, and then you can just pull these things up, and they should be able to pop back in there, but I can remove the Phillips head screws down here, and we can get this board out to also service now.
All right, guys, so I apologize if I'm a little bit out of focus. I've been working with this lens here on this setup, so that doesn't really matter, because we're going to switch over now. We're going to look at some photographs, some really high-quality stills that I took of this restoration process. So let's go ahead now, and we'll take a look at it. Okay, so I'm going to walk you through this as I basically have worked through these entire boards already. And I will note that I always take this photographs as I go, before and after. And the real reason for that is in case I run into any issues down the road as I'm servicing this. I want to make sure that I have seen everything. I have documentation. So if I have a question as I'm servicing it about what the condition of the board was prior to me working on it, I can always refer to my photographs and see even something as simple as the orientation of parts, and if a capacitor is a true value that I thought, or if I had a question about a specific part. It's always great to be able to look back at these photographs of the boards. So that's what I've got, is the documentation process. Now, this was a partial cap kit on this major board, so not every single capacitor was removed. We kept this to power, filtering, and the deflection capacitors. And also anything that's in a high heat zone is also considered. And then we will, if there's anything else that looks dodgy on any of these parts, as part of the inspection, I'll go in and I'll use a meter, a tool called a GME in-circuit capacitor tester, and I'll test these capacitors if there's any question as to whether we should replace them. So these are the ones that have been removed. Once I remove all the capacitors, I can go in here and take photographs of everything, and you can see there's still plenty of them that are remaining on the board, but those were all good and not part of a deflection or high heat capacitor kit or anything. And this is a picture of the back side of the board, and I won't stop on all these photographs and be in detail, but another one is the neck board or the CRT socket board, and all the capacitors that were electrolytic were removed on this board. And you know, when you put these in the meter, even out of circuit, and they start to read higher on the ESR or ohms, and they start to fall closer and closer to out of spec, it's just them degrading over time. Again, 20 years on these parts. Plus, these parts were rated for 85 degrees, not 105 degrees. So that does also contribute to lower, life expectancy. This is what this board looks like as I remove capacitors in it. And I've also reflowed solder on a lot of it already. You can see the socket itself has fresh solder on there. And so do these connection points where you have wires coming in or going out to any other part of the TV. That's what you should always reflow the solder there. There's the capacitors that we've removed. And then you can see that I've gone in here, and any of them that I've tested that are good or replaced, I've gone outside of, I've installed them, and then I've gone outside and cleaned it, and then I've come back and QC'd it all. And then when I make a mark like this, it just means that I've checked the capacitor and it's the correct rated capacitor. The polarity is good, and I've also checked out the solder integrity again, just to make sure that nothing's bridged, there's no issues. You really should go through and check all your work. I can't tell you how many times I've accidentally installed a capacitor upside down or the wrong direction or the wrong component, and I've caught myself by doing these post-servicing inspections. And again, if you have anything in question, then you can refer to the photographs from the original CRT. Now, this is what this board and these boards look like post-servicing. So this is completely checked out, QC'd, cleaned, obviously, solder reflowed, and I mean, this is about as looks as about as brand new as you're going to get it to look, right? I mean, that looks awesome. Not to toot my own horn. Here's this other board we talked about that has the velocity modulation coming out of it, and some other controls. Again, these are all near heat sinks, lower rated capacitors. Since we've already pulled the board, we're going to go ahead and do the same kind of thing with it. Reflow solder. As you can see, that's why these solder bulbs are here. Reflow solder, remove capacitors, take pictures, and then we'll move towards installing new ones. There's that process. Same kind of thing. Check everything out. Make sure you've got the right parts in there and that they're pointed the right direction. And then after you've cleaned everything, just check all the solder joints. Make sure there's nothing cracked, nothing bridged. And we can even see from our photograph here that there's nothing wrong with that physically if you're just inspecting it visually. All right, so there's that. There's the main board. Everything's set back up. And there it is, all pieced back together, cleaned up, and ready to test. So that's where we are right now. It's set up next door here. So let's jump over and set it up and see what it looks like when we feed a signal into it. Hopefully we didn't do anything wrong.
Well, I finished up restoring the CRT. Now it's been reassembled. Let me add some light here. It's much cleaner inside. I've quadruple checked everything. I mean, beyond checked. Everything's been checked over 1, 2, 3, 4, 5 times just to make sure that I've reassembled everything right. That's why I always take a lot of pictures before I take something apart. I did have to clean all this, obviously. And there's the second, I don't know, neck board right there. You can see the fresh capacitors. Neck board itself, the CH, is looking good, rebuilt. And then in here I replaced every deflection capacitor, and I went through the rest of the board and QC'd those other caps. And if I found any other bad, which I did, I found 6 other bad ones, I changed those out. Everything else tested good. And now it's all put back together. I have the Super Nintendo here turned on, plugged in with best of the best here, HD Retrovision cables. We're going to just test out component video here on this, and hopefully everything's good. I cleaned up everything else too on the outside of this, and let's just see what we get. Standby light, and there we go. Isn't that good? Normal. Video 6. Perfect. Okay, great. Excellent. Let's make sure everything is working and continues to work. I'm not promising this is going to have great geometry or anything like that. These sets usually don't have the best geometry, but they do have good color. Yes. All right.
All right, so now we've got it fully serviced, but I want to kind of show you some things closer up of the actual geometry and the way the screen looks. And we're going to talk about kind of one of the pitfalls of these flat screen, larger Sony late model CRTs. All right, let's just look at this TV real quick. Now the colors really do pop. It looks great as far as red, green, and blue. And I do like the aesthetics of the TV itself. But when we start to look in here at things like, there's again a great representation of what the color is. You have really full balanced color as far as red, green, and white, or red, green, and blue, which ultimately gives you good white balance. Now, if we look here closer at this, you're going to see issues mostly on the edges right off the bat. Now, it's not like gigantic problems, glaring issues, but there's going to be almost a slight rippling kind of going down the edge here. And sometimes that's due to the velocity modulation, but also it's because these CRTs really struggle to get great edge geometry, and that's just part of geometry on a tube and CRT in general. The only way to get that better performance is from professional hardware and broadcast quality hardware that actually goes up and has extra power, extra hardware to improve your geometry and give you better control over the edges. These standard televisions really don't have the capabilities to give you great geometry along these edges, and sometimes you're going to have trouble with convergence. Another thing you'll notice is we do see some of the bottom edge here, and then it dips down. So there's another issue where you kind of have a ripple going both ways, vertically and horizontally along the edge. Now see, this is going to show you a good example of color separation up here in the corners. Even with adding things like convergence strips and recalibrating the convergence rings, you're still generally stuck with some impurities as far as convergence goes on these consumer grade televisions, especially in the corners. You'll notice some bleeding and push out of the blue here on the edges. And this corner is a little bit better, but again, we can definitely see that color separation really start to happen up here at the very top edge. Now, thankfully, that's way up there in the top edge, and you really shouldn't be staring at that part of the screen unless you're just crazy anyway. But it is there, and you'll notice, again, you can find these spots throughout the screen where you're just going to have imperfect color convergence, and it happens. There's pretty good convergence there. Again, over here, we've got some blue bleed out at the very bottom. The center convergence is really nice, though. What we've done is we've used as much of the hardware as we can. It can get better, and calibration adjustments. You can get better here in the center of this screen, and then it works its way out, and it just seems to get worse and worse and worse as it does expand out farther. So that is pretty much everything that I want to talk about with geometry, where you're going to have pictures. Now, the last thing I will mention on geometry, you will have people complain about almost a linearity problem with these tubes, where you may have a ripple effect going on the center, and that's with something that scrolls either horizontally across the screen or vertically. It will give this ripple effect where it's just like, instead of being a straight down or straight across pattern, it'll just warp a little bit, and it looks like bad linearity. And that, unfortunately, is just a byproduct of a lot of these CRTs and these WEGA Trinitrons that are the high-def ones and the larger ones. And especially if you jumped into those widescreen and 16:9 versions of this television and the newer ones like that, you're really going to encounter this barreling effect and probably worse geometry along your edges and worse convergence controls than what you even saw in my pictures today. All right, so I know that's being very nitpicky with the CRT. We're really getting in there and, giving it a hard time on a lot of these things. Honestly, if that was the only issues with it, it would be a great, wonderful television to use for retro gaming because of its Swiss Army knife approach to its input board. I mean, we're talking about everything from RF all the way up to HDMI, and we can do everything from 240p and go up to 1080i, and we have a wide range there of accepted video signals. Now, honestly, the biggest issue with this CRT and these CRTs in general that have HDMI inputs on them is display lag and latency. I did a multiple round of latency tests on this CRT with my Time Sleuth device. I tested all the inputs, including the HDMI inputs and the component inputs, and even the analog video inputs that were the composite and S-video inputs, just to see if there was any processing going on those strictly analog video signals. And unfortunately, every single signal did have some kind of video processing going on that was adding latency to the television. Now, the worst case on this was in the form of 60 hertz 480i. So this would have been actually over the HDMI port and the component video port. I seem to have a lot of display lag right there, where we were getting up into that 48 or 49 milliseconds up there on lag. So that was about the worst. Now, when I changed over to 240p, which is essentially analog video, also, it was just the same story. Again, we were getting that 48, 49 milliseconds of latency, which is kind of, what is that, more than a frame of lag, I'm thinking? Definitely. So that's not so great if you're really tuned in to latency. Now, I did manage to get, there's again the latency, and I did manage to get the latency down a little bit when I went over and was using 480p. All right, so there was a 480p mode that was actually lower latency, and I was incorrect on what I explained to you the first time. This was the HDMI port. It was only down to 14 milliseconds for 480p and above on what I tested there. So that dropped it down to a very low latency level. So there still was some kind of frame buffer or something, again, processing this video signal. But once you started using the HDMI, you could really get that down, and it was consistent on both ends of this thing. You were getting that consistent same amount of lag. So ultimately, if you're used to this kind of lag and it doesn't bother you that, or depending on what you're playing, it may not make a huge difference. But I do know one of the biggest things people use CRTs for, and the reason they're still used today, has a lot to do with the latency and the lag effect compared to modern displays that all have somewhat of a tiny amount of latency built into them. These obviously have some latency built into them also due to the frame buffer, I'm imagining. and you can get it down like I'm showing right here by using the HDMI port. But again, if you go back and you just want to use this for analog video, it's not the greatest option, because you're going to get 48 to 49 milliseconds. Woo, what a special CRT. Yeah, I love it. I mean, I do actually like this TV. I like to cover things like this. These things really do need to be explored. We need to find out which one of these TVs do have latency, don't have latency, do have great geometry, may suffer a little bit from those things, what actually happens when you use them. So at the end of the day, it's still a fun TV, and the owner was still really happy with the servicing done to it. And if that's that's really the most important thing, is that they're satisfied and everything came out well. And again, just because I'm nitpicking the small minor details on this TV doesn't mean it's not still a great option for some people. I do just want you to know these things and not just see some trendy video telling you that these widescreen HDMI, all, you know, analog to component and all the way up from 240p to 1080i TVs are just the bomb and perfect and all the greatest thing in the world, because they are not the greatest CRTs, frankly, that are made out there. And that's really the truth about it. Now, look, I appreciate you all for hanging out this entire time. This has been a long video. If you did stay to this point, you know, drop me a comment below that says 169 for 16 by 9. 169, baby. Drop it below, and let's have some fun. Thanks again for joining me. If you want to get a CRT service, you can also check out the link in the description for this video. That goes and takes you to my Patreon page, and that's how everybody gets their CRT professionally serviced by me. And you will get a full breakdown of your CRT being serviced like you saw in this video here. Every CRT and board and device that I service gets a full photograph file that you saw us go through on this video today. So that's all part of that restoration package. Anyway, guys, I thank you very much, and I'll see you next time with some more CRT madness.